Being mentioned, I'm Claire Ruddy. I'm with the WCS Engagement and Planning team here. I've also spent the last decade working in the environmental sector, advocating and designing programs for resident engagement on things like decarbonized energy and energy conservation in our homes and businesses. So it's really interesting to sit here and see this from the other side. It's been a really great opportunity. So I'm excited to be here with the panel today, or our panel. Our panel discussion for the next hour is going to be focused on designing for resilient prosumers. So we understand that the exponential growth of distributed energy resources is enabling the transformation of traditional consumers into prosumers. So really what we're looking at through this hour is what are some of the roles of architects and building engineers can play to aid resilience in the distribution network by considering early in the design process how to use less energy and how to supply energy efficiently, maximizing the performance of equipment and building services. So I'm just going to let the panel just quickly introduce themselves, who they're with, role, and where they've traveled from, because we've got quite a mix of people from. Go ahead.
So I'm Andrea Deeb. I'm the one who comes from London. London in the UK, and I work for Fosters and Partners. We are an architectural and engineering company. We work around the globe, so not only in the UK, we have projects in Canada and all the way.
Yeah, Ramtin, Chief Technology Officer at Energy Palak, and our factory is going to be at Malahot, Victoria.
Good afternoon. My name is Jan Buick. I work for AB Energy Canada, and that does not mean Alberta Energy Canada. It's actually a company headquartered in Italy, founded by a fellow by the name of Angelo Baranchelli, so that's where the AB comes from. We are producing modular CHP systems and also RNG upgrading systems, and I'll get into that a little more later on in the discussion this afternoon.
Great, thank you. So just to let you guys know how we're going to run the panel, we are going to start off with a presentation from Andrea. We're going to then have Jan and Ramtin talk about the work that they're doing and some of the innovation and needs that they're seeing. And then we're going to move into questions both from between the panelists and from all of you. And then we'll wrap. So we've got 60 minutes. We'll roll in. Without further ado, Andrea.
Okay, I hope this works. So, very interesting presentation from the mayor. These projects are now, as I said, from around the world. So I'll come to the front. Find that a bit better. So this particular design was actually done in Abu Dhabi, and it's Mazda City. And it was completed in 2014. So from this design, you can already see the integration of the buildings, the city, the urban design with solar farms and energy storage. So that's me. I've got a 20 years experience just designing what is now the prosumer, actually the consumer side of the energy systems. I've worked in medium voltage networks, low voltage networks, and you name it. That's who I work for, Norman Foster's. The studio started back in 1967. We've worked in projects in North America. We have a project in North America at the moment, many projects in the Middle East, Southeast Asia, and so on. I put 2 projects on the screen so then you can recognize us. One of them is the Apple campus. The second one is here, not here, but in Vancouver, Jameson House. I don't know if you guys know this project. And my manager worked on it all the way from London. So, and he was very proud of this project. So we are going to go very quickly through the energy transition, which you all know about. Talk a little bit about the architectural and building engineers' scope. And I have 2 case studies. But first, how did I end up here? I did a very short sort of, it was an article in our own website which draws back from this particular cover, which was back in 2003. And the cover says, "Architects pollute." So back in 2003, architects that were around at the time were very unhappy with Discover, but they realized they had to do something about it. Between then and now, there was a lot done in terms of energy efficiency of the building fabric and the building itself. And that in the last 10 years, we see more and more of requirements from clients or even local governments and so on for us to add renewable systems, energy storage, or any type of energy generation on site. So this is happening right now. And why is that? Well, the UN estimates that cities consume around 75% of the total energy around the globe, and then we produce in cities 60% of the total greenhouse gases. Then what happens next is that national grids, as we all know, are moving away from decentralized systems. That give us the opportunity to then, when we are building a site, when we're planning a new urban city, we then add the renewable systems and the energy storage with that city, and that's what we do. And why is that? We all know about the energy transition. We need to see more renewable systems in the national grid. And we also see a global demand for electricity. So this global demand for electricity is not new, it's based on the electrification of transportation, electrification of heat, which is big here in Canada as much as in the UK, and also our need for data and AI. So how do we deal with this change? How do we deal on the consumer side? We see every project as an opportunity to change. And we start from a very simple rule of passive design, Mayor Compton just spoke about it. And it's the idea of being lean. So you start by looking at the major features of a site and try to have your building in a way that you maximize those features in the building. Then be clean means that, and when we have to supply a system, the system itself will be efficient and will be sized just to the load that is required. Be green means to add renewables and energy storage. And be seen is the idea that once the system is on site, the user of that particular site or that particular building needs to know what they're using. So monitoring the systems is actually quite important. And what is our approach? As I said, we look at clients' requirements. The user requirement is very important for architects and engineers. We then do a demand assessment of the building in terms of electricity, heat, cooling, and water. And we look at opportunities of the completely different types of systems, how we can use them on site. So for instance, we can use PV cells with energy storage. We can also use CHP systems as and when required, or any other system that we see suitable for that particular building. So that's the beginning of a study of a building in this building is in Qatar. So it's the first study of the building facade. So the solar access of this building was very important. We were trying to limit the solar access. Once we did that, we then could optimize the renewable systems on site and also look at generation methods based on the seasonal variation in that particular region. That's the end result. So in terms of this particular site, we look at a facade design which shaded the interior building, the interior part of the site from the sun, centralized thermal storage. We use PV cells in roof areas, water recycling, which was extremely important for that part of the world. And when we did the final fit out of the building, we added a smart building to the tenant spaces so they could integrate or they could understand the systems they were using. Yeah, so for those who like football, this building was featured as the backdrop of one of the World Cup stadiums. My second case study is very far from home, but it's something that you guys can think about. So it's a resort in the Maldives. And the reason why I put that in there is because you can relate to areas in Canada which are not really connected to the grid. So in this particular case study, we look at ways to design but not use the actual land because we were limited on the amount of land that we had. So we had a passive design of the buildings of this resort. We then looked into the active systems, and they had to be minimum because the power supply were via floating PV cells and also PV cells at roof levels. And then we added energy storage to this site. This resort's not built yet, so it's still, we're still planning. So to finish, and then to start our conversation, understanding energy generation, storage, and integration is nowadays essential to architects and building engineers. We need to look beyond the building envelope, and we need to look at solutions that are available now and solutions that may be available in the future. Thank you.
Great, thank you. Thank you for kicking us off and grounding us in our topic today. So we're just going to go along. Maybe, Jan, do you want to start with telling us a little bit about what you're doing and how it relates to designing for resilient consumers?
Yeah, so I've spent my life selling stuff to people that they don't need. So when you have a building, a factory, you get electricity from the grid and you burn gas in your boilers for your heating needs. And I've been knocking on those doors day after day, year after year, telling them it's much better to invest in a cogeneration system where you then produce your own electricity and heat at a lower cost, environmentally more beneficial than the separate production of power and heat. So I've over the years been involved in many of those projects, CHP at hospitals, universities, industrial facilities, and that has a cost benefit. It also has some environmental benefits, and as we're talking about resiliency as well, it also becoming clear that this really improves the resiliency of the energy system in these facilities. And if you look back over the past 20 plus years or so, we've seen some major events in the North American market. I think it goes back to 2003 when there was this major power outage in the northeast US and Canada, where the grid was out for 2 weeks, and an on-site power generation system running on natural gas at the time, you still had light and power in your building. If you had a diesel plant, a lot of facilities had emergency power. You would have power, but it would be limited to how much diesel fuel was still available in your tank. And when there's a widespread outage, then it's hospitals and other critical facilities that get priority. And if you are not a priority site, you're done. Yeah. So resiliency is very much dependent on when all fails, how much storage do you have on site? How much can you still generate when the grid fails? So we saw that resulted in a focus to make emergency power more resilient, and that resulted in the Canadian code CSA 282 being amended to allow for natural gas to be used as fuel for emergency power. Then I think it was in 2013, ice storm hit in apparently Ontario and Quebec. And again, this time mid-winter, around Christmas time that major grid outage. Yeah, the only source of power available was on-site power that had access to gas. So that brings me to, okay, what is next? Yeah, because natural gas is the next big focus on carbon reduction. So if you start looking at how do we improve or maintain a certain resiliency, but we want to decarbonize, so they say, okay, but what alternatives or what options do we have in the corner of the power generation market that I'm active in? And then it's okay, what alternatives are there? Yeah, so one option is renewable natural gas. We see that a lot of what traditionally has been power generation on biogas that is shifting towards upgrading biogas, so removing the CO2 to natural gas quality and inject it in a natural gas pipeline. So that has a minimum site changes required. You can simply continue to run on natural gas, but now purchase renewable natural gas, which is effectively carbon neutral fuel. You can start blending in hydrogen. Yeah, so a lot of equipment can actually run on a blend of 20% hydrogen and the rest natural gas. So that already lowers the emission level. Or you can run on 100% hydrogen. And that's what Andrea brought up. The slide is, I can still see it on the screen here, showing a hydrogen tank. So the challenge that you run into with hydrogen is that the equipment is there. Yeah, so you can absolutely produce 100% power generation, 100% output, running on 100% hydrogen. But the infrastructure to get the hydrogen to the site is where there's a major challenge today. Yeah, because Andrea, you were talking about, we were speaking earlier, and maybe you want to talk about the challenges that you face when
exactly.
You're looking at hydrogen and how much space that may take. So back to you.
Yeah. So we have this one project that is still, we are still planning, and the client requested us to look at different sources of energy. And we looked at hydrogen, and once you put the hydrogen tank on site and the plant on site, it takes so much space compared to other plants that sometimes it's a hard sell to certain clients. Just because in certain parts of the world or in certain areas, you are limited to the site that you have. You cannot simply have certain systems because perhaps they have the best level in terms of carbon emissions, but sometimes it's not suitable for that particular site.
Right, and on that note, Ramtin, we'll throw to you.
Yeah. So at Energy Palag, we are, first of all, very proud of our partnership with the Malahot indigenous community in Victoria. Together, we are going to build the first Canadian gigawatt factory over there. And at the factory, we are going to have two different lines of production. One, I'm going to call it large-scale battery, LFP batteries, which is typical these days, 20-foot containerized solution, 5 megawatt hour, which can be used for data centers, for the voltage frequency regulations of the grid, and many more, since for the last 2 days, many already covered. So I'm going to escape to the second line of production, which is more novel, I guess. And that one is a small scale, anything from 20 kilowatt hour up to 100 kilowatt hour. We call them pole mounted and pad mounted. And why we call these guys, we had a conversation with BC Hydro, Toronto Hydro, Hydro One, Electra, different utilities, and we realized that there are crazy amount of poles And perhaps at your neighborhood, you saw a lot of pole-mounted transformers, right? So they asked us, why not you are building something, a battery energy storage, turnkey solution, everything into a IP65 enclosures, which can be mounted on the pole, and from the form factor, looks exactly like the transformer. So that's what we've done for them. Now we are trying to decentralize the grid, and what benefits is providing, first of all, deferring the expansion of the grid, which is very expensive, and for the utilities as well, for the demand response, for the helping the reliability and resiliency of the grid. And by doing that one, we can create a mesh system as well. All our systems, they are going to talk to each other to make sure we can provide the power as fast as possible. And since I talk about this one, one thing that is very exciting for us is how we are integrating the machine learning AI system into our, I'm calling it advanced energy management system, ultra-fast power management systems, and many people, they call them microgrid controllers. And whatever I'm talking about is built in Canada. We are not bringing anything from the other countries, from the hardware, software, and also the controllers. All of them, they built in Vancouver or Victoria. We are using very advanced methods even before deploying to the site. Something like the control hardware in the loop or RTDS. So we are tuning the controllers, then doing the tests, and then going for the site installation. And one of the other things for this pole mounted that I realized I missed is when we were talking to them, we realized around 20 to 30% out of almost 20 million poles in Canada, they have transformers on it. So that one is a big market for it. And on top of that, a good portion of it, especially in Vancouver, for instance, and the British Columbia, those poles belong to TELUS. So you can imagine how much other benefits we can bring it. Because right now they have lead acid which can last for a couple of minutes, so we can provide communication, UPS function as well. And the other last part that I'm going to touch about it is going to be our business is not just about the tech and business really. It's about economic reconciliation as well. We are bringing the indigenous community into the leadership roles within the energy sector and providing the training opportunity for them to make it a sustainable business. In a way, they can do the business if we are not working even over there. And by providing such a business model, we got a call from other, in US they call it tribes, indigenous tribe, and they want to have the same model over there. We go there, building the factory, providing the training opportunity for them as well. Yeah.
Great, thank you everyone. It's interesting, you know, we're talking about the scale of a pole versus the scale of the hydrogen tanks, and you have the site that you have, so lots of interesting dynamics there and opportunities that you're talking about in terms of different innovations. One of the things that we were talking about in preparing for this panel was really how when you're designing and working with architects and planners is that you really have to design with and integrated energy systems in mind, using local data and computer models, predicting the most suitable sources of energy, whether that be heat pumps, solar, PV, RNG, hydrogen. For each of you, I'd like to invite you to talk about what is something that you're seeing that is a real opportunity. Like, what's your challenge statement to people who are in this room as a way that they can support more resiliency for prosumers through the design stage? And maybe I'll start with you. Oh, okay. We'll just go. We'll go along.
All right. When thinking about that, I'm based out of Ontario, so I'm very much involved in Ontario energy politics and policy, and how Ontario is starting to panic about new capacity that is required for addressing the growing demand as they forecast, and the forecast is actually growing faster than what was anticipated. So when I look at where Ontario is putting a lot of attention right now, is that they are adding nuclear to the grid. They are expanding solar and wind, and they have also natural gas as a major contributor. They look for about 1,000 megawatts of gas-fired generation. But they are starting to see that the public is no longer supporting large gas-fired generation. Yeah, so anytime there's a large project being considered, it is facing a lot of public opposition that municipalities will not and cannot support the large gas-fired generation. So we believe that there is an opportunity to do this a lot smarter. And I missed your talk yesterday, Brad, but I know you were talking about CHP in greenhouses, and Ontario has a huge greenhouse sector, and this is where I think is a major opportunity to address the energy needs for a province like that, and I can see it possibly in BC as well with the significant greenhouse sector that is in the Delta area. But this is where greenhouses, they do need CO2. Yeah, so you want to maintain a CO2 level in the greenhouse of about 1,000 ppm. A CSP plant can run with if the greenhouse needs lights for grow lights. At that point, power goes into the greenhouse. When the engines are running, heat is being recovered. If the greenhouse doesn't need the heat, it can be stored in the large buffer tanks. That a typical greenhouse will have 3 million, 10 million liter tanks to store hot water when they are when there's need for CO2 but not for heat. When the lights are not on, the CHP plant can run to produce the heat for the greenhouse, and power can go into the grid. So this can be a really flexible generation that is producing when either the greenhouse needs the power or the grid needs the power. Exhaust can be cleaned up to the point where it's safe enough, clean enough to be sent in the greenhouse for the plants to actually benefit from the CO2. And it's supported by the public. Yeah, so it's fully integrated in the greenhouse sector. It's supported by the municipality. It makes the greenhouses more competitive. And to just give you an idea of the magnitude of what can be accomplished, in the Netherlands, where I'm originally from the Netherlands, is also a very large greenhouse sector. And in the greenhouse sector there, about 4,000 megawatts of capacity of high efficiency cogeneration with exhaust cleaning and CO2 recovery is deployed. So 4,000 megawatts in a market that is about an 18,000 megawatt power market. So more than 25% of the electricity needs in the Netherlands actually comes from, we're talking about prosumers, consumers that also produce electricity very efficient at very low emissions. And I think that is, where in Canada, in Ontario, in BC, also in Alberta, there are several greenhouse facilities, growing greenhouse presence. So I think there's a huge opportunity to support the energy needs of Canadian provinces in this sector.
Fabulous. There's this. I was interested listening earlier to the idea of to talk about value stacking. We have a huge composting facility here in the Sea to Sky, and we've been talking for years about putting a greenhouse on it so that we can use the heat to heat the greenhouse year round. But now we should put we've got another layer to add. Love it. Okay, Ramtin, for yourself.
Yeah, I'm going to talk more about some challenges that I can see, how we as Energy Public try to address them, and what yet needs to be done. I'm going to talk more about that one. And one of the things which is very important is energy security and sovereignty. What happened during the corona? Many utilities, they wanted to have the battery energy storage, but the price was very high, or the lead time was crazy, right? So what we are doing, we are trying to work on providing some sort of supply chain to address it by building them in the Malahat community over there. And the other thing, which is very important and many times downplayed, is the human resource. How many experts do we have really? So if we have novel technologies, how many people they feel comfortable of using them? What about the operation? What about the maintenance, right? And for that one, we are trying to provide the training opportunities. It's very slow, but we have started doing that one. And the third one is the cybersecurity. For the cybersecurity is one thing that we are very proud. That's why I said all the controllers, clouds, data, all stored in Canada and made in Canada, which is one of the big differentiator, and how fast they can do the calculation, how in a smart way they can make a decision when and how the energy needs to be deployed or stored. So these are stuff we are working on it, and what I believe is a challenge that we couldn't address is the lithium-ion production. I said all of them, we are doing very great jobs, but from the cell itself, unfortunately, we are relying on the other countries. We are importing it, and it's not something that we feel comfortable of doing that. You never know what would happen and what kind of the quality you would receive it, and if it can be a sustainable import from them, right? So that's one thing that we open our eyes. If there is any partners, they are producing the cells, we would be more than happy to work with them as well.
Right. And Andrea, for yourself, what is one of the biggest opportunities, challenges and opportunities that you see for the design stage for resilience for prosumers?
I want to see from the others first. I think from my side, resilience, interesting that we talk a lot about, perhaps in the office or perhaps in my day-to-day life, it's more about the new buildings, how to do a new building, how to make the new building resilient. But the current building stock is there to stay for the long term. And it's important to address the problems that we have with the current buildings. So how to make the current building stock, the current cities more resilient. There are many systems that you can implement on site. I think in this room I saw many different ideas which were quite interesting. And I think as a designer, one of the challenges that we have is that the systems by themselves, they look great. When you try to integrate them into something that is existing and still trying to make that existing building somewhere pleasant for the user, that's where the challenge starts, because sometimes the system is too big, sometimes the system simply does not fit the building fabric. And that happens over and over, so you end up with a product that is not exactly the product that you're expecting, but you have to use that because of the conditions that you are given on site. So real site conditions are very different in big cities or even in remote cities. Real site conditions with buildings are very different from what we see when the system is on its own.
Right, thank you. We'd committed to making sure that you guys had time to ask each other questions before we open it up for public, to the audience. So now that we've all heard a little bit more about what each other's doing, I invite if anybody has questions for each other.
I can start. So, Jan, what do you feel about the CHP industry, and how has that changed over the years with the idea of renewable systems, and combustible units not being something that people want to use?
Yeah, I've seen quite a few changes over the years. Yeah, where years ago, and I was trying to measure my career in decades now instead of years. But initially, the focus was all on operation 24/7, cost of electricity versus the cost of gas, and justifying the investment based on the return that you could achieve by operating at a lower cost compared to buying power and gas from the grid. That started to change with utility rate structures changing to encourage certain customer behavior, time of use rates, that electricity daytime use became far more expensive than nighttime use. So you started to see the hours that you could justify running were going to be quite reduced. Yeah, so many time of use rates are 16 hours a day from 7 in the morning till 11 at night. On work days, that is when rates are higher and nighttime lower. So from 8,300 hours a year, you go to 4,000 hours a year as the operating hours. And then rates started to change even further, specific to industrial clients with a certain demand, that what you contribute to the utility peak ultimately sets how much you pay for the electricity, for the capacity, the demand that you have. And that meant that in certain jurisdictions, it's really all about capturing that peak. Yeah, so you go from 4,000 hours a year to 300 hours a year. Yeah, so you see that the market conditions are really as market rates change, you see the operating profile change, and that has caused me to respond to customers saying, you're investing in an energy asset, and whether this is solar or hydrogen or cogeneration or whatever energy technology, storage you invest in for your building or for your facility, it's a 20 or 30 year asset, a project life or a product life of 20 or 30 years. But the way you plan to use it over the next few years, it will change. Yeah, so I've seen companies invest in CHP with initially the expectation that they would run 8,000 hours a year. That after 5 or 10 years, the market had changed to a point where they no longer were running 24/7. They were specifically targeting the utility peaks because that is where the revenues were. Yeah, so it's always about, okay, I have all these different assets available to me, the market will then determine how can I best utilize these assets to optimize my energy usage, minimize my cost, maximize the resiliency, the reliability, and that is something I've seen over the years. And then layered over top of that today is how can I contribute to lowering carbon footprint? Yeah, is it reducing running hours? Is it improving the efficiency? Is it changing the fuel that is consumed by these machines? So it's a very dynamic environment. It changes, ongoing changes that impact how you actually use the asset that you have.
Ramtin, do you want to ask a question just so we don't know?
Described very well. Actually, not that much question.
Okay.
Yeah. if I want to ask is what kind of really how you want the energy storage to be combined with your system, or how we can do it to make it easier for you to use them. From our side, what we do, we try to build our system to be the master brain of all the DERs and control them by ourselves. So that's something that you prefer to have it, or your controllers take the lead.
Yeah, I've always looked at energy storage as the technology that really balances supply and demand. And if I relate it to CHP and power generation, ideally our equipment runs at high loads for as many hours as possible. So when we look at storage as part of our systems, let's say you have 5 days a week that loads are very high and then the weekend very low, then we can see running a few hours on a Saturday to store electricity and then have a lower level of discharging of batteries to address a low load in the facility. That's one way of combining storage and generation. Where we see some interesting application right now is traditionally we've seen data centers been mentioned a few times. Looking for location, get grid power, put some standby power in there, and their mode of operation was drop power from the grid. If the grid is down, there's a battery of diesels to back up the power. Grids around the world are so stressed right now that data centers are starting to look at locating to where a fuel source, an energy source is. They start to locate where's natural gas available as a fuel that's available. A standalone power plant powering a data center has difficulty dealing with the volatility of the demand in an AI data center. So you now start to look at energy storage as the balancing tool, yeah, to deal with that volatility. And yeah, we see all kinds of interesting applications there on combining these technologies. At its core, I think storage is really what allows for maximizing renewables. Yeah, solar, wind, yeah, and then I see gas as the backbone. If all else fails, there's still gas to produce some power. Yeah, that remains my core belief in where the different technologies do fit. But then working together, yeah, this is an example of where we see a lot of coordination between storage and generation.
Thank you.
Jan, do you have a question for one of your fellow panelists, or we can go to the floor?
Yeah, well, back to Andrea on the hydrogen. Yeah, it's we see a lot of publicity and information around hydrogen. A lot of attempts to develop hydrogen technologies. In the urban, the building environment, the architecture that you're active in, how do you see the future of hydrogen? Yeah, because on the one hand you talk about storage, but is there an expectation that this will evolve to hydrogen being delivered to buildings the way natural gas is being delivered to buildings?
Yeah.
Yeah, what is your perspective there?
So in terms of what we see, and I can see the markets that I'm actively working on. So in the UK, they had a pilot project which was to substitute the gas supply to a few houses to hydrogen. And I think I briefly told you or someone else about it. there was some backlash from the houses, from the people in that particular community, because they were selected to use them, to be the guinea pigs, to utilize hydrogen other than gas. So I think in terms of, as a designer, we try to be in the forefront of this new technology, or any type of technology, not just hydrogen. But for instance, we've had in the office the idea of small nuclear plants supplying some of our sites. And there's always going to be some backlash on this type of design, innovative design, which is, are you really ready to use it? Is the site ready to use? Do you have all the safety measures? Or do you have to look back and see someone else trying first, so you are 100% sure that it's going to work on your site? So there's always this idea that we can try something new, but when you try that new technology, you don't know everything that is going to come with that. But we're always trying. We're always trying to include new designs. We always do a lot of research on different types of design. So recently we did a research on different types of battery systems and the correlation that we have in terms of their energy storage and the energy storage that you would get from a diesel generator with the fuel tank. And we just did that for our on-site resilience to see how much space we would need on-site if we were to supply that site from this generator. Then you change that to a fuel cell with hydrogen, and you change that to many types of battery systems. And the amount of space that you need is completely different. I think when you get to the fuel cell, with the hydrogen storage, it had to be an outdoor space, and it had to be sort of segregated from the building itself. So as I said, it becomes really illogical to use certain systems in certain applications.
That's an interesting example. When it was the Olympics, we had a showcase project where we had hydrogen buses around Whistler, and we definitely had a bus depot that was a bit bigger than we needed as a result, but we found other ways to use it. Okay, so I'm just going to open it up to you guys to invite you to ask questions to our panelists. It's the post-lunch lull. Yeah? Get ahead of time? Craziness. Okay. So thank you then, guys. I want to get your help in thanking our panelists, and thanks for being here today. Thank you.
Thank you.
Thank you.